Well, howdy do, folks. Hope you're having a good day, and we're going to be talking today, and you're going to be watching a video. This is for May 13th, Wednesday, and this particular video has to do with light and lasers. So, first of all, I'm sure you all have seen lasers before. Lasers are used in a lot of places these days. But I wonder if you recognize the fact that the word laser is an acronym. So, what's an acronym? Well, that means that name each of those letters in that name stands for something, all right? And it has to do with light. So let's look at the acronym lasers. So first of all, here's an example of an acronym before we get specifically to lasers. This one's on classroom behavior, and you notice that the acronym is the word shine. Well, sometimes they spell a word, but other times they don't. Sometimes it's just the first letter of the name or of something, right? So think about when you're texting or online, BRB is an acronym. It's not a word. It means be right back, right? Or sometimes LMAO, laughing my ass off, right? And then sometimes it's not used as much now as it used to be, but LOL, laughing out loud. Well, sometimes I didn't mean laughing out loud. Sometimes I meant little old lady. That's an appropriate acronym, right? All right, so let's look at this next slide. So laser is an acronym, and it stands for the following 5 words: light, amplification, stimulated, emission, and radiation. All right, so it's actually light amplification by stimulated emission and light radiation. They didn't repeat light a second time. So in this case, when we think about light, we want to think about the fact that we're talking usually about visible light when we talk about the lasers that you've seen before, but they also do have lasers that work off of infrared or UV, X-ray, as well as gamma rays. Amplification refers to the concentration of only one wavelength. So we're going to talk about that here in just a second. That's called coherent light. So whenever you have a laser that you're using, you're working with coherent light rather than incoherent light. Incoherent means it's a blend of lots of different wavelengths, like you see right here on this particular image where it says white light's being passed through a prism, and then you get all these different colors, which if you remember learning these in elementary school, you should have learned that the list is ROYGBIV, which is Roy G. Biv. And amplification refers to only one of those wavelengths at a time. Stimulated refers to the source, so wherever it is you're getting the source of light. Emission refers to what type of light's being produced or emitted, and radiation refers to the way that light moves. There are 3 different ways that matter and energy can move, or heat and energy can move, and one of them is by radiation. So you're going to be listening for these concepts on the video, the ideas of wavelength and frequency. So remember that all light, even in the light that we can't see, what we would, I guess, call invisible or not visible spectrum, can be broken down into 2 or measured in 2 ways. You can measure it by wavelength, or you can measure it by frequency. So wavelength, if you notice on this diagram here to the side, wavelength is the distance between the same 2 points on the same point on 2 consecutive waves. So in this case, what they're measuring is peak to peak. You can also measure trough to trough or midpoint to midpoint, but you get the idea here. You've got short wavelengths and you've got long wavelengths. So if you have short wavelengths, that's going to be a small number. Short wavelengths travel at a high frequency, and long wavelengths travel at a low frequency. And how do I know that? Well, when you think about wavelength being the distance and frequency being the number of waves that travels past a point in a minute, all light travels at what? All light travels at the speed of light. So if all light travels at the speed of light and you multiply frequency times wavelength, guess what you get? You get the same answer every single time. You get the speed of light. So it's possible to calculate wavelength if you know frequency, and it's possible to calculate frequency if you know wavelength. But just keep in mind that the bigger the wavelength is, the lower the frequency is going to be. The shorter the wavelength is, the higher the frequency is going to be. And all of this has to do with energy, which you're going to be watching on this particular video. So for each color, you have a specific wavelength and wavelength and frequency. And on the video, you're going to actually see 3 different types of lasers. So what this technically means is if you have a specific frequency and a specific wavelength for every single one of these different 7 colors, you could create a laser that would emit every single one of those colors. So I've seen seen lasers, and I'm sure you have too, that are red. Red lasers came out in the late 20th century, around the 80s or so. They became affordable in the 1980s. Now you can buy them at any pet store because people love to tease their cats with red lasers, right? Green lasers came out around and were affordable around the 2000s. I bought a green laser back in the late 1990s because I did hiking, and green lasers are particularly good if you're out hiking, or if you're out at night and you happen to get lost, you need somebody to find you. They can actually spot you from the ground with a green laser. If somebody's standing on one peak and you're on another place and you shine a green laser up into the sky, it actually diffracts and can be seen from great distances. And people use them also when they're out doing, well, they call them star parties, but it's when you're out with a telescope and you're looking at stars and you're trying to point out something in the night sky. You can use a green laser and point it at a star, and you actually can track the pointer. You know, you can't do that with a red one. And what about a purple laser? If anybody has not seen a purple laser before, it's only because you may not be aware of the fact that that's what runs a Blu-ray player. That's going to be explained in the video as well. So be sure that you're paying attention to the video for these particular questions. You've got a worksheet there that you're going to be answering. Make sure 2 things on this worksheet. Number 1, you write your name on there legibly so I can read it. It needs to be important to you because this is a grade. You need to put your name on there so that I can read it. If I can't read it, I'm not going to struggle. You just won't have a grade, and you need all the grades that you can get. Number 2, make sure that you circle clearly the correct answer. I'm not going to guess on those either. If you don't circle it clearly, then it's not going to be a correct answer. We want to maximize our scores here, guys, so let's get after it. All right? Hope you're having a great day. Looking forward to doing Friday's video with the news questions. Hoping to be answering some really great ones. Take care. Bye.